Okay, sorry. Now I think we're ready. Okay, lies I was told about collaborative editing. So I'm Alex. I just wanted to talk a little bit about what my motivation is to give this talk. So professionally in my day job, which I'm not really here to talk about, I work on a collaborative text editor. And when we started the process of building this, we found it super hard to get practical, actionable advice about how to actually do this. I'll talk a little bit more about what we're trying to achieve, but my main motivation in this talk is to tell you more or less the stuff that I wish that we had known ahead of time. So I think I'm just gonna talk about some stuff that surprised us, stuff that I think you're gonna wanna know, like guidelines that we found helpful when, after having done all of this work. And then if we have time, I'll go over a very simple example. We sort of copy and paste open source our implementation and put it in a GitHub repository, so you guys can go check it out. Oh, sorry. Okay, so to start off, stuff that surprised us. So survey time. So let's say we have a document, and the document just has one sentence, and the sentence is just the color of pomegranates, okay? So there are two users, okay? There's Alice and Bob. Bob is British, so he changes the word color to have the letter U in it, so the British spelling of the word color. And then Alice just deletes the whole paragraph. Okay, so they're both offline. They both come online. What should happen here? Okay, so we're gonna vote. Okay, so if you think that it should be an empty document, please raise your hand. Okay, if you think that it should be the British spelling of the sentence color of pomegranates, please raise your hand. And Canadian, yeah. And if you think it should be something else entirely, raise your hand. Okay, so I think, I'm not a vote scientist or whatever, but it looks like roughly even in each bucket. So if you guess something else entirely, that is exactly what the off-the-shelf collaborative editing libraries do. I'll tell you exactly what they do, because they all do the same thing. If you've ever used YJS or Share.js or any of the CRDT implementations or the operational transforms implementations, it doesn't really matter. They all do the same thing, which is that they produce a document consisting of the letter U. The letter U. That's right, just the letter U. No. So if you're like me, right, you're like, WAT. So this doesn't make any sense to me personally. I feel like in the readmes of all of these projects, they say things like, we support offline mode. The latency that we will tolerate is anything from 0 to the heat death of the universe. And then there's people writing tweet threads about CRDTs and how they magically solve this problem. And you know, so I work on a collaborative rich text editor. I'm very much in the market for a silver bullet. If you have a silver bullet, I would love to talk to you about it. I am the target audience for any technology that is plausibly going to do something like this. And I feel like I've been told this for years, that this more or less works offline. What I learned in this process is that I think I have a different definition of works than the rest of the people that are implementing these libraries. So I'm here, I'm ready for you to learn from my pain. We've come out the other side of this. I want to talk a little bit about this specific circumstance. So let's talk about direct editing conflicts. So direct editing conflict, what I mean is like you have two people, they're editing roughly the same bit of text, so in this case, like the color of pomegranates. So we did a lot of user testing. I think the first thing that surprised us is that in 100% of cases that we tried, direct editing conflicts, when we trusted a collaborative text editing library that was based on CRDTs, and we simulated offline automatic reconciliations of two concurrent offline edits, users viewed the reconciliation as data corruption. Okay? So I'm not here to say that people are bad people or whatever, but like that's just a fact. When we ran the user test and we gave them examples like this, like the color of pomegranates test, users viewed that result as data corruption. They asked us why we corrupted their data when we put this in front of them. Okay? So So what I'm going to say is, this is not an algorithms problem, okay? I'm going to argue this is not an algorithms problem. This is a UX problem. This is the number one thing that I want to convince you of, because I think that if this was possible, like, again, we would be in the market for this kind of thing, but for our use case, for our specific use case, we're building like something that feels a lot like Notion or Google Docs. This is the number one surprise that we had when we actually sat down to actually implement this stuff. And so I want to build a little bit of intuition for why this is true, because I think it's important to kind of understand the laws of physics here. So let's imagine we have two Postgres nodes, okay? So if we are accepting Alice and Bob are both writing to these different Postgres nodes, okay, intuitively, if I put some CRDTs between the two Postgres nodes, if you go ask your database person, like your DBA or whatever, I can just put CRDTs between these two nodes, and it'll just like magically all work out, right? They'll be like, no, absolutely not. That is not how that works. There's technical reasons for this I'm happy to talk about afterwards. There's this, like thing that database people are into called like causal order, but there's no magical solution to this. I think for some reason, the main thing that I think about is like, if you have like a Postgres node and like what was the second Postgres node is actually a desktop app, there's some kind of bit that flips in our collective imagination that suddenly everybody thinks that this is something that will behave fundamentally differently than if we tried to do that replication over Postgres itself. And I just think that that's not a very helpful model if you want users to be able to predict what's going to happen to their data. So when I say this is not an algorithms problem, it's a UX problem, I think it's worth stepping back and thinking about what we're really trying to accomplish here. And I think the way that I think about this is, at least for our users, if you have incredibly technical users, I think this might be a different story. We do have technical users, but the number one tenet of UX for us is that users need to be able to predict what happens to their data. If they can't predict what happens to their data, then it doesn't work for our specific product circumstance. And while I would like to be a completely offline, completely local first app, I don't think that means that we've absolved our responsibilities to our users to allow them to predict what happens to their data as they interact with it. So I do have a bunch of thoughts about this. I think one is that given that users interpret results as data corruption, like when you give them a scenario like the color of pomegranates test, right? You say what should happen here, and you give them the result, and they interpret the result almost invariably as data corruption. I think that what that means, at least in our case, is that the number one UX win you can provide is to help users to avoid direct editing conflicts. Okay? So if you're offline, so the easiest way to do this, of course, is just have a presence indicator, right? Because that is how users are going to steer away from direct editing conflicts. That's the number one UX win, because there isn't like the thing that I will argue is that there isn't actually a way to do automatic reconciliation in a way that makes sense to people. And so the normal way that we indicate to people that they should steer clear of an area is we put a presence indicator. This is a huge UX win. Maybe at the risk of sounding obvious, I think that has like a number of implications for the kinds of UX that we can build, and I'll get into this later. But the second thing is that if you can't do that, like if you can't actually power live presence indicators, I think that it is really important to try and model your domain so that there are fewer direct editing conflicts. Okay. By that I mean, like if you think about Linear, say. So Linear is a great app. Linear does pretty much, it lets you just edit freely offline, and then when it comes online, it syncs. And I think that probably works for Linear because I'm not an issue tracker expert, but my understanding of how Linear works is that their model is that users aren't going to be editing precisely the same text in an issue, generally speaking. They're probably going to be commenting on stuff or changing the status. And in that case, it probably does make sense that like the last writer wins, okay? But that works because they're separating the edit domains. They're modeling their domains so that the likelihood of direct editing conflicts is not that high. Another thing that I'll note here, which I think is kind of unintuitive, is that if you're doing something like last write wins, which is, as far as I can tell, what Linear is doing, That is the same thing as, what that privilege is the user with the lowest connectivity. And the reason is because the user with the lowest connectivity will sort of dip out, and then they will come back, at some point, and then they'll sync whatever they had. But their document at that point is almost always incorrect, right? From the perspective of the other users who are collaborating on the document. So in some sense, last write wins privileges the person who is least likely to have the correct document in a sort of very fundamental way. So I think what this goes to show is not linear is bad. Linear is a great product, but what this goes to show is how far it can take you to model your domain so that conflicts are less likely to happen. Because you can have something that is seemingly as catastrophic as a conflict model, which will almost certainly take you back in time or corrupt your data from the perspective of the other users. But if you do a good job of making your domain match what make your domain such that people are unlikely to have direct editing conflicts, then you can still have a very pleasant, very modern feeling product to use. So if you can't do that, I think you should consider UIs where conflict resolution is kind of built in. Not every product can do this, but a good example of this is Git. So in our product, I'm not really here to talk about our product, but our product is kind of like, it aspires to be a Google Docs-like, Notion-like rich text editing tool where everything is marked down under the hood. And so for us, it is possible to do something like power a diff, and because our users are primarily developers, it makes sense to render a diff to people if they have long divergent forks or something. But not everybody can do this. So like if I gave this to my dad or something, I'm not sure that he would understand what exactly is going on here in the case of like prose text. So I think if you can't do those things, you may just have to suffer. And I wish that, so again, if you know something that I don't, I would love to hear ideas of I would love to hear ideas for how to solve these problems. But at this point, I think those were, at least for our product context, those were the things that, those were the options that appeared to be viable in our case. Another thing that I wish, okay, so remember the talk has like basically 3 parts. So the first part of this talk, I wanted to sort of convince everybody that to think about direct editing conflicts kind of differently than I hear normally talked about online. The second part of this is sort of a more minor point, but when we went to implement our collaborative text editor, we found it surprisingly very challenging to achieve like 60 frames per second. So a thing that we believed is that as you are editing a document, you should, like no matter how many other editors there are, no matter how many other readers there are, the fact that they're reading or writing your document should not imply that your editor becomes slow, okay? So this is actually surprisingly hard to accomplish just with normal off-the-shelf technology. The reason for that is if you look at, if you go pick something off the shelf like Share.js or Y.js, which are OT and CRDT implementations, a thing that we found to be true is that for large numbers of readers, for anything more than like 10 or so readers, you would have an appreciable CPU memory consumption. Your render thread ends up consuming a bunch of resources just to try and reconcile all of these changes together. And if your product objective is that the editor runs in 60 frames per second, that means that every update has to fit into the 16 millisecond window, okay? So what that implies is that the server, so like in our case, I'll tell you how this works for us, and I'll sort of show you the code in a second. But for us, what that implies is that the server's job is to chunk up changes into contiguous bits that can be applied within this editor window, so that as you're broadcasting it to other users, you're not slowing everybody down. I don't run into people very often who have who have tried to use this technology to implement this kind of like to implement a text editor or something like that with this kind of performance guarantees. And so I think if we had known just this fact ahead of time, we probably would have not even gone down the road of evaluating a lot of those technologies, just because I don't think we could ever have a highly contended doc and not slow literally everybody's editors down. Okay, does this make sense, by the way? Does everybody maybe a little bit abstract, but I think I put this up here as an example of the only other place I've ever seen anybody ever talk. Anybody ever talk about this as an issue on the library for ProseMirror Collab commit, which is the library that we use to coordinate changes between clients. This is the only time I've ever seen anybody talk about something like this on the internet, and it's like a kind of obscure comment. The repository doesn't get that much traffic, and if you work on a text editor and you have problems that are similar to this, I would love to talk to you about it, especially if you're using a library like YJS. Anyway, there's a lot of text. I just wanted to mention it because I think that they do good work. Okay, so now the final part of the talk. So at this point, I hope that I've convinced you that collaborative text editing, especially offline-first collaborative text editing, is maybe harder than it seems. So primarily, I think that's because of fundamental, when we got started, we just had a fundamentally incorrect, in my view, I think I had a fundamentally incorrect view of what was even possible in a situation like that. I hope that this makes it clear what kinds of things are possible and what kinds of experiences you can build with off-the-shelf tools. This part of the talk, we have sort of taken our implementation of the text editor and we've made a copy-paste rewrite of it and put it in a GitHub repository. I just want to talk through how this works. All of this is sort of contained in the repository, but I want to sort of talk through how this works for us. So in the first case, we use a text editing library called ProseMirror. I think ProseMirror has a reputation for being somewhat hard to use. It is hard to use, but it is also a marvel of engineering. There's so many bugs where it's on Safari version from 10 years ago, this event doesn't propagate in the proper way, and there's a thing that works around that. It has 15 years of accumulation of that kind of bug fix, and as a result is very performant and very stable. The thing that I think, if you're using React, the main place that everybody gets tripped up, and I wish we'd known ahead of time, is that you want to use the New York Times React ProseMirror library, okay? I think it may be literally impossible to get ProseMirror to work with React without this library. And the reason is because ProseMirror has a fundamentally different attitude around how state should be updated and how that should be rendered as a view than React does, and those life cycles are not compatible at all. So I should say, they didn't put me up to this, but the authors of the library are super, super good, and if you're implementing something like this, I think it is worth considering consulting with them because there are just not that many people who you can hire to actually do this work yourself. So for us, I think one of the main challenges of building a collaborative editing system that works in a variety of places for clients with arbitrary latency is that, and I think you should think of building a collaborative text editor as building a database, right? I think everybody knows the #1 rule of computer science is don't implement a database, but nobody talks about the second most important rule of computer science, which is don't accidentally write a database and not admit it to yourself. Collaborative text editing is a database problem. What I mean by that is that clients send transactions to the server. The server's job is to take those transactions, detect conflicts, tell the clients about the conflicts. If the transaction is successful, broadcast that out. If that sounds familiar, that's because that's literally what a database does, right? The thing that makes collaborative text editing tricky in particular is that the semantics of rich text transactions do not fit into the traditional query model of something like Postgres, okay? So the way that we solve this problem is, you can solve this problem in a number of ways. One way to solve it is using Cloudflare durable objects or Reboot.dev. Both of those companies have booths here, so I encourage you to go talk to them. But in both cases, the reason why it is easier to implement collaborative text editing on top of these technologies is because they both give you the invariant that there is either zero. If I say I want a room for this document, Cloudflare durable objects and Reboot both give you the invariant that there is either 0 or 1 copy of that room anywhere on planet Earth, okay? That's very helpful because it means that you're never going to get into a split brain problem where you have one room that thinks it's leader and another room that thinks it's leader, and then they can't merge back together. I really recommend talking to them. There's other ways to solve this. You can use Redis and stuff, but I think that's probably the easiest thing. But most importantly, I think you should go visit their booths because they're both sponsors. So last thing, we use ProseMirror Collab commit. This is a library that you can use that will take transactions from multiple clients, sort of help you negotiate and merge them together. You can use, there's other libraries that do this, but this one property that this has that I think is really helpful is that it does the batching for you automatically. So if many clients are writing to the server, you can accumulate quite a lot of steps. You don't necessarily want to apply 500 steps from 500 writers at once because that will impact your ability to render at 60 frames a second. ProseMirror Collab commit handles this automatically, okay? And it's relatively wire efficient. So how does Collab work? I'm debating whether or not to go into this because I was going to show you, like, there's not that much code. I guess I'll go through it really quick to give you a sense of like how easy this is to implement on something like durable objects. By the way, durable objects is not paying me, or Reboot and durable objects are not paying me. I just think they're good. So there are basically like two operations that you need to support. Okay, so any client that is connecting to the server, which is the source of truth for the document, needs to be able to fetch recent changes, and it needs to be able to submit changes. And then optionally, it needs to be able to get the current state of the page if it falls too far behind or something like that. Now, this is in Reboot because we wrote it on top of Reboot. So again, it's like a copy and paste rewrite of how this actually works. But you can see like this is not actually that complicated. We're basically using off-the-shelf like an off-the-shelf call to ProseMirror Collab commit, and this works really well. This looks like not a lot of code and maybe seems like not that impressive. The thing that I will say is that the reason why this code is short is because we made so many mistakes trying to get to this point, right? We spent so much time evaluating all of these other collaboration libraries to get to a solution that is maintainable, right? Oh, sorry, I should say the product context of our product is that a specific goal that we had is that we're a team of 4, so we wanted one person to be able to own the entire collaboration stack from key press in browser to persist on disk. So it's very important to us that we use one library for doing collaborative editing. This short code is the product of a ton of learning and dealing with terrible bugs and stuff like that. But you can see that now that we've learned all of this stuff, we can boil it down to just a couple of calls. And I really recommend it. You don't have to use our code. It's free, it's open source, it's MIT licensed. But if you were starting on a journey like this, I really recommend like looking at it and trying to understand how that code actually works, because I think it will help, especially if you're starting and you don't know anything about this. I think it will help you to build it in your context, which may not be amenable to using durable objects or whatever. Changes is a lot easier. You just get the changes and you return them back to the users. Okay, so I put a QR code here in case you want to go look at the open source repository. I am Hausdorff Space on both Blue Sky and also Twitter. Officially, we're actually here to hire you. So if you like the idea of working on complicated, truly local first collaborative applications, and you want to work with a team of 4, a small team of 4 generalists, and our office is like 2 blocks that way, we would love to chat, but that's officially why my ulterior motive here is that I want to hire you. But yeah, if you want to talk about this stuff, we also have a booth downstairs to talk to people about hiring. So you don't have to come find me. You can just come find our booth. Okay, so I was told to leave 2 minutes, and I think that is it. So.